Jai Hind, dear students. I am Dr. Vimlesh Mishra, Assistant Professor in Department of Applied Science, Ajay Kumar Garg Engineering College. Today, I am going to teach a very important topic of relativistic mechanics, which is the part of engineering physics, KS 101T. So, let us start. So, I will briefly cover these topics: frame of reference, inertial and non-inertial, Galilean transformations, Michelson Morley experiment, postulate of special theory of relativity, Lorentz transformation. So, these are backgrounds of special theory of relativity, and using these in today's lecture I will derive variation of mass derivation, which is very important, and then I will discuss some important applications. So, frame of reference. Frame of reference is nothing but coordinate system, which is basically we all know that Cartesian coordinate system is spherical system. So, an arbitrary set of axes with reference to which the position of motion of something is described or physical laws are formulated. So, a set of 4 coordinates axis x, y, z, t will form a frame of reference. All motion is relative. In each case, a frame of reference is a part of description of motion. Framework that is used for the observation and mathematical description of physical phenomena and the formulation of physical laws, usually consisting of an observer, a coordinate system, and a clock assigning times at position with respect to coordinate system. So, this is two types. One is inertial frame of reference and another is non-inertial frame of reference. So, here are some important points about these. Inertial frame is basically a frame in which all the laws of Newtonian mechanics is valid, especially law of inertia. That is why it is called inertial frame of reference. Non-inertial frame, Newton's laws are not valid. So, example of inertial frame is a train moving with constant velocity. An example of non-inertial frame is a freely falling elevator. So, Galilean transformation. So, this is first transformation derived by Galileo, and this is most fundamental. So, here we have taken two inertial frames S and S prime. Frame S prime is moving with constant velocity v in positive x direction. So, x prime is equal to x minus v t, since v t is the distance between these two frames at any time t. So, this is first Galilean transformation, and y prime is equal to y and z prime is equal to z. So, these three equations are known as Galilean space transformation, and fourth one is t prime is equal to t. So, this equation 1, 2, 3 and 4 is known as space time Galilean transformation. So, it was position coordinate transformation. Now, Galilean velocity transformation. So, as we know that Vx prime is equal to dx prime by dt. So, d by dt of x minus vt is equal to dx by dt minus v. Dx by dt is nothing but Vx, component of velocity in x direction, and v prime is equal to vy and vz prime is equal to vz. So, basically in x component velocity will change, and in y and z component there will be no change. So, these equation 5, 6 and 7, 5, 6 and 7 are called transformation equation. So, now acceleration transformation. So, a x prime is equal to a x because v is constant. Similarly, a y prime is equal to a y and a z prime is equal to a z. So, equation 8, 9, 10 are called the Galilean acceleration transformation. So, acceleration is invariant under Galilean transformation equation because there is no change in acceleration when we go from one inertial frame to another inertial frame. But in case of velocity and position, there is change. So, acceleration is invariant under Galilean transformation, but velocity and position is variant under Galilean transformation. So, ether hypothesis. Ether is basically a hypothetical medium for transmitting light and heat filling all unoccupied space. So, it is imaginary medium, and it was thought that all these planets, earth, sun, moon, they are moving in an imaginary hypothetical medium which is known as ether. So, it was needed when the velocity of light or electromagnetic theory according to Maxwell, formulated by Maxwell, but Newtonian physicists postulated ether as a medium that transmitted electromagnetic waves. So, ether was held to be invisible without odor on such a nature that it did not interfere with motion of bodies through space. The concept was intended to connect the Newtonian mechanics wave theory with Maxwell field theory. So, now Michelson-Morley experiment. It is very important experiment. It is the basic experiment from where relativistic mechanics or special theory of relativity started. So, in this experiment, Michelson-Morley performed an experiment to prove the existence of ether by finding the relative velocity between earth and ether. So, it has simple experimental setup. It has two mirrors M1 and M2 and a source S and a telescope T. So, it is basically Michelson interferometer with some modification. So, in this experiment, Michelson-Morley calculated the time difference or path difference between two beams which is going in direction M1 and M2. So, using Galilean transformation, they find out path difference delta is equal to 2 L v square by c square, and when they substituted numerical parameter of length, velocity and c, so they find this fringe shift n is equal to 0 point, means almost less than half of fringe will shifted when we rotate the position of mirror M1 and M2. But in experiment, the fringe width was 0. So, this Michelson-Morley got negative result because theory and experiment does not match. So, explanation of negative result. So, there are three theories, theories: ether drag theory, length contraction theory and light velocity theory, and fourth one is Einstein's postulate. So, these theories, ether drag theory and length contraction and light velocity hypothesis, they cannot explain this negative or null result of Michelson-Morley. So, Einstein offered to postulate that forms the basis of a special theory of relativity. So, here is the foundation of a special theory of relativity. Einstein gave two theories, one is general theory of relativity and another is special theory of relativity, STR and GTR. STR is special theory of relativity applied to inertial frames and GTR applies to non-inertial frame. So, this postulate number 1 is known as law of equivalence. All the laws of physics are equally applicable in all inertial frames. So, this is postulate 1. Law of constancy of speed of light, this is postulate number 2. The speed of light c is universal constant and the same in any inertial frames. So, this is 2 postulate. So, based on this postulate, Lorentz derived 4 equations, and they are known as Lorentz transformation equation. So, basically according to Einstein, this Galilean transformation are not hold goods for very high velocity compared to the velocity of light. So, Lorentz derived these 4 equations, equation 5, 6, 7 and 8. X prime is equal to x minus v t divided by under root 1 minus v square by c square, y prime is equal to y, z prime is equal to z, t prime is equal to t minus v x by c square divided by under root 1 minus v square by c square. So, these 4 equations 5, 6, 7 and 8 are known as Lorentz transformation equation, and it is supports Einstein 2 postulates, especially that speed of light is constant or invariant in all inertial frames. So, this is inverse Lorentz transformation. In inverse, what we do? We take velocity as minus v and we shift s to s prime. So, first one is x is equal to x prime plus v t prime divided by 1 minus v square by c square, y is equal to y prime, z is equal to z prime, t is equal to t plus t prime plus v x prime by c square divided by under root 1 minus v square by c square. So, this is inverse Lorentz transformation equation. Now, this is the application of a special theory of relativity or Lorentz transformation. So, first application is length contraction. So, we are not going to do this topic in detail, because today we will discuss variation of mass with velocity. So, in short, I will introduce this topic, length contraction. So, if we take 2 frames, frame S prime and frame S prime. So, if we call frame S is fixed frame and moving frame S prime, and if you put a rod or if we associated rod in x direction with length L0 and coordinates of end points of this rod are x1 prime and x2 prime with respect to frame S prime or moving frame, and coordinates of same rod with respect to fixed frame, that is frame S, is x1 prime and x2 prime at the same time t. So, according to general concept, L0 is equal to x2 prime minus x1 prime will be the proper length or normal length, which is represented by equation 1, and length L, which is equal to x2 minus x1, is known as non-proper length or length measured by fixed frame. So, according to Lorentz transformation equation, x2 prime is related to x2, x1 prime is related to x1. So, this x1 prime and x1, they are related through Lorentz transformation of space and time. Here we have taken time t same, otherwise we cannot define this non-proper length L. So, if we substitute these two equation in equation 1, so L0 is equal to x2 prime minus x1 prime. So, x2 minus Vt minus x1 minus Vt. So, we got L0 is equal to x2 minus x1, which is L. So, L0 is equal to L divided by under root 1 minus V square by C square, or L is equal to L naught multiplied by 1 minus V square by C square. Since this factor under root 1 minus V square by C square, this is always less than 1, since V is always less than C. So, this factor 1 minus V square by C square is always less than 1. So, this length L always less than L naught, proper length. That is why it is called length contraction, not expansion. So, this is the reason we call it length contraction. Time dilation. So, this is another application of Lorentz equation, Lorentz transformation equation. We again use same principle, same equation, Lorentz equation, to derive this time dilation. So, here this is time dilation equation. So, T0 is proper time and T is non-proper time. Here this factor under root 1 minus V square by C square is coming in denominator. So, time, so non-proper time will be greater than T naught. So, it is called as time dilation, delay. Delay means time dilation, is expansion of time. So, these two are the fundamental applications of special theory of relativity. So, in the case of meson particle, it is found that time dilation is a real effect, it is not an imaginary effect. We are not going to give detail about this. This is in case of mu meson. If we use this special theory of relativity, then only we can explain the life cycle of mu meson. So, principle of simultaneity, it is also an application of Lorentz transformation equation. Addition of velocity. Addition of velocity is basically nothing but velocity transformation or Lorentz velocity transformation. So, sometimes you call it addition of velocity or relativistic velocity addition theorem. So, for the derivation, we use V is equal to dx by dt. This is the velocity of a body with respect to frame S, and u prime velocity of an object with respect to S prime. So, using Lorentz transformation equation, we derive a relation between u prime and u. So, this is the relation. So, this is with respect to frame S, and this is with respect to frame S prime. So, u prime is with respect to frame S prime, and u is with respect to frame S, and v is the relative velocity between frame S and S prime. So, this equation which we are going to use in variation of mass. So, this is basically direct equation, and if we invert, so we get inverse velocity transformation. So, what we do, we take v as a minus v. This is the simple trick to get inverse transformation. So, we are going to use these two equations to derive variation of mass. So, this is variation of mass with velocity or relativistic mass formula. So, till today we are knowing that mass is constant, but today we will see that mass is not constant, but function of velocity. Mass is basically function of velocity. That is why we call it variation of mass with velocity. So, if we take two inertial frame S and S prime is moving frame. These two frames are inertial frame, and we have taken two identical objects A and B. These two identical objects have same mass, identical, and their velocity is also same, but in opposite direction. So, this is the picture with respect to frame S prime. So, after some time they stick together and velocity will be 0 with respect to frame S prime, but with respect to frame S, its velocity will be v or u. So, now by applying the law of conservation of momentum on the collision of the balls in frame S prime, so as we know, momentum before collision is equal to momentum after collision. The momentum before collision is m u and m minus u. So, this is 2 m v. So, this is m u, this is the momentum of first body, and this is momentum of second body, and this is the total momentum after collision. This v is the velocity of combined mass after collision with respect to frame S. After collision, the collapsed mass must be at rest in frame S prime, hence it moves with velocity v in frame S. Now, let u1 and u2 be the velocity and m1 and m2 be the masses of balls A and B respectively in frame S. Using the law of addition of velocities, the above velocity can be written. So, this is the formula which is known as addition of velocities, which we have seen in earlier slides. So, u1 is related to u and u2 is related to minus u, because u1 is the velocity of object A and u2 is the velocity of object B. So, this is equation 1 and 2. Applying the law of conservation of momentum on collision of the balls in frame S. If I apply the law of conservation of mass on the collision of balls in frame S, so we get m1 u1 plus m2 u2 is equal to m1 plus m2 into v. So, this is equation number 3. Now, by substituting the value of u1 and u2 from equation 1 and 2, So, here u1 is u plus v 1 plus uv by c square, and this u2 m2 into u2 is equal to m1 plus this is plus m1 plus m2 into v. Now, by rearranging these terms, take m1 in one side and m2 in another side. So, we get m1 into u plus v divided by 1 plus uv by c square minus v is equal to m2 v minus u plus v 1 minus uv by c square. So, by doing algebra, so we get u plus v minus u v square by c square. So, v minus v get cancelled, here v minus v gets cancelled. So, finally, we get m1 multiplied by u minus uv square by c square 1 plus uv by c square is equal to m2 minus uv square by c square plus u divided by 1 minus uv by c square. So, if we see this numerator, this is same in both the equation. So, this portion will gets cancelled. So, finally, we get m1 divided by m2 is equal to 1 plus uv by c square 1 minus uv by c square. So, this is equation number 4. The above equation makes a relationship between the masses of balls in frame S and their velocities in frame S prime. Now, to obtain relation between masses of balls and their velocities in frame S, we proceed as follows. What we do? We take square of u1 square. So, this is value of u1, we take simply square of u1, and what we do? We divide by c square and subtract from 1. So, 1 minus, so consider, basically can start that, consider 1 minus u1 square by c square is equal to 1 by c square u plus v divided by 1 plus uv by c square whole square. So, what we do? We take LCM 1 plus u by c square on whole square, 1 plus u by c square whole square, 1 by c square u plus v ka whole square. So, if we open this first bracket, we get 1 plus u square v square by c power 4, then 2 u v by c square, this is the first bracket till here, and this second bracket, u square by c square, this is first term, v square by c square second term, minus 2 u v by c square. So, this term got cancelled from 2 u v by c square. So, we get 1 minus u1 square by c square is equal to 1 minus v square by c square minus u square by c square. So, these two are common. So, if you take 1 minus v square by c square as a common, so we get 1 from here and u square by c square from here. So, finally, we got 1 minus u1 square by c square is equal to 1 minus v square by c square multiplied by 1 minus u square by c square divided by 1 plus uv by c square ka whole square. So, if we take 1 plus uv by c square on right hand side and rest term in left hand side and take under root. So, we get 1 plus uv by c square is equal to under root 1 minus v square by c square, 1 minus u square by c square divided by 1 minus u1 square by c square. So, this is equation number 5. On similar ground, if we calculate 1 minus u by c square, so we get equation number 6.
थोड़ा डाउन हो गया
अभी अभी टाइम हो गया ना?
यस सर 30 मिनट हो गए सर.
शुरू करें? ओके. तो on similar ground we can relate 1 minus uv by c square to u2. So, from equation 4, 5 and 6 we get 1 plus uv by c square divided by 1 minus uv by c square is equal to under root 1 minus u2 square by c square 1 minus un square by c square, and which is equal to m1 over m2. So, if we do cross multiplication, we get m1 1 minus u1 square by c square is equal to m2 under root 1 minus u2 square by c square, and take it as m naught, because this is for system A and this is for system B, but both are constant. So, we take a common value m naught as a constant. So, this is let we are assuming. So, from these two equations we get m1 is equal to m naught divided by 1 minus u1 square by c square, and from these two equations m2 is equal to m naught 1 minus u2 square by c square. So, from here we can see that m1 and m2 is nothing but depends on velocity, and in general we can write mass variation formula as this. So, here m0 is basically mass at velocity 0. It is known as rest mass. So, this is mass variation formula. Since the two bodies are identical, the rest mass of body is also this same thing in common use notation. So, this is relativistic mass variation formula, and when velocity v is much less than c, so v square c square may be ignored. So, this m is equal to m naught. So, this m is known as relativistic mass or moving mass, relativistic mass or moving mass, or m naught is known as rest mass. So, both mass will be identical if we take v is much less than c. So, this is not an imaginary or appearing formula, it is in reality happens when we do experiment where we measure E by m ratio of charged particles. So, if we calculate E fast, if we take two kinds of electron beam, one is slow and one is fast. So, E by m for fast beam and E by m for slow beam, this will not be equal, because in case of fast m, fast will be higher than m slow. because mass depends on this velocity, as mass variation formula suggests, m is equal to m naught 1 minus v square by c square. So, m v is always greater than m naught. So, the correct relation will be, this will be less than. So, E by m for fast beam of electron will be less than E by m for slow beam. So, this is experimental verification of mass variation. So, today we are going to stop here. Next things we will discuss in another lecture. Jai Hind students.